Hello friends, welcome back. So in the previous video we learned about the different types of trigonometric equations and how to solve them. Here we'll be taking the specific questions and trying to see how to use what we learned in the previous video. So the question says, find the general solutions of the following equations. There are a few subparts. The first subpart is cot theta plus cosecant theta is equal to root 3. So we note that cot theta and cosecant theta both have sin theta in the denominator, right? And again, as I said in the previous video, we should try to bring them to sin theta and cosine theta because that makes it very easy for us. Right? So let's see how to do that. Okay, so cot theta is cos theta by sin theta. Cosecant theta is 1 by sin theta, right? So now I can take this to the other side, root 3 sin theta, right? Now I bring it to one side, right? Root 3 sin theta equal to 1. Now if you remember, we did one specifically for this kind of equation. That was a cos theta plus b sin theta equal to c. Now there the condition was c should be less than the root of a square plus b square, and it's pretty obvious why, because cos theta lies only in the absolute value should be less than 1, or it lies in the range minus 1 to 1, right? And we see that here it's 1 here, it's minus 3 here. So 1 plus root 3 square is 2, which is greater than 1. So this equation can be solved. Now let's divide by that, right? So you have 1, you have minus root 3 squared. Now this is 2, right? So let's divide by this. What do we get? 1 by 2 cos theta minus root 3 by 2 sin theta equal to 1 by 2. But what is the left hand side? Now 1 by 2 can be written as cos of pi by 3, right? So this is cos of pi by 3, then we have cos theta, then we have minus sin of pi by 3, sin theta. This is nothing but the formula of cos of a plus b. Please note that, be very careful with the cosines. So people tend to make mistakes here. It should be cos of theta plus pi by 3, not minus pi by 3. So we have cos of theta plus pi by 3, and cos 1 by 2 we know that is cos of pi by 3, right? So writing them as in general form, we get that theta plus pi by 3 is equal to 2 n pi plus pi by 3. Really sorry, it should have been minus here. When you take it to the other side, it becomes minus 1, minus 1 minus half, and this is 2 pi by 3, right? So subtracting here, we get theta is equal to 2 n pi plus this is a general equation. I'm pretty sure you all remember general equation is the one where we write in terms of all general angles possible, right? This is where n obviously is an integer. The next one is tan p theta plus cot q theta equal to 0. So obviously you can't find out answers just like that. It's because p and q are completely unknown. So what we will do is we can actually use again write them in terms of cos and sine, but note that tan theta is sine by cos, and cot theta is cos by sine, right? So if you take if you actually do it that way, the things will be bit more uncomfortable. First of all, because we're dealing with p theta and q theta, not just theta, and second because then you will have cos square, sin square of different argument, plus you will have some cos theta sin theta term. So actually you will be making it slightly tougher. So what we will cleverly do here is, we know that we will try to express cot of q theta in terms of, or tan of p theta in terms of the other of their own co-trigonometric function, right? So because tan theta is slightly more common, I'll express it in terms of I'll express cot in terms of tan. Now we all know that cot of something, or rather minus cot x, is tan of pi by 2 plus x. So tan of pi by 2 plus q theta should give us minus cot q theta, right? Now invoking the writing, you get q theta equal to n pi, because n pi gives us the all the general solutions, plus pi by 2 plus q theta. So we have p minus q theta is equal to, we can take 2 as a common denominator, or theta we can write as 2n plus 1 pi by 2 times p minus q, right? So you see that when we take it in terms of tan and cot, when we express cot in terms of tan, this becomes a whole lot easier than taking in terms of cos and sin. So the next one is pi sin squared x minus 7 tan x cos x plus 8 cos 2x plus 4, right? Now we did one which is very similar to this. So and bringing it to that form is very simple. Now, that involved, instead of cos 2x, that involved cos squared x. Right? So we just need to use the identity of cos 2x equal to 2 cos squared x plus 1. Okay. So cos 2x is 2 cos squared x minus 1. So let's put that here with 5 sin squared x minus 7 sin x cos x. 8 times 2 cos squared x minus 1, that gives us 16 cos squared x minus 8. Minus 8 plus 4 becomes minus 4. Okay. Now we see that a plus d is not equal to 0. This was our a in the equation we learned then. So we'll just divide throughout by cos squared x. We get 5 tan squared x minus 7 sin x cos x by cos squared x, this is tan x, plus 16 minus 4 secant squared x. Secant squared x can be written as 1 plus tan squared x Okay, so now let's combine all the terms here. So for tan squared x, the coefficient should be 1, minus 7 tan x plus 16 minus 4, that gives us 12. So this is a simple quadratic in tan x, the root of which are very simple. You can see that tan x equal to 3. That's 9 minus 21 plus 12 equal to 0, and tan x equal to 4 also gives us the solution. So minus 3 tan x minus 4 is equal to 0. Right? So let's consider both of them. Tan x equal to 3. If tan x is equal to 3, now we learned about the trigonometry. We don't have any standard angles for which tan x will be equal to 3. So we will be just writing in terms of the inverse trigonometric function we learned in the previous video. So this can be written as x is equal to n pi, right? Tan inverse of here. This is one solution. The second is tan x is equal to 4 or x is equal to n pi plus tan inverse of 4. Right? So in this question, we saw that this identity was very useful. Cos 2x equal to cos squared x minus 1. Once we write it in terms of that, then it becomes very simple and we can express everything in terms of tan x, and then solving is not a problem. So the next question now. Now this was the one I was talking about when I said high degree terms of sin x and cos x. So now let's see how to solve this kind of equation. Sin power 10x plus cos power 10x equal to cos 2x power 4, right? So now we know what sin squared x can be written in terms of cos 2x, right? Because we see that there is one cos power 4 2x. So we will try to put everything in terms of cos power 4 2x. What are the equations identities we are going to use? For sin squared x minus cos 2x, and similarly cos squared x is 1 plus cos 2x. So let's expand using this. So we have 1 minus cos 2x by 2 power. Now this is not 10, this is 5, right? Be careful there. And we have cos 2x by 2 power 5 equal to cos power 4 2x. Now you can see that, forget the denominator here, 2 power 5, that's 32. So that can be easily taken out. But what you have in the numerator is pretty interesting, right? So you have 1 minus cos 2x power 5 and you have 1 plus cos 2x power 5. Now if you don't know how to simply write these equations in a very simple way, you can just expand them right now and you'll see what happens usually with these kind of equations. Okay. So let's expand the terms here. Now I will take 2 power 5 as common and just multiply the whole equation with that. So I should get 32 on the right hand side. And here I get 1. Now, if you know binomial theorem, this is pretty simple to expand. What you get is 1 minus 5 cos 2x plus 10 cos squared 2x minus 10 cos cube 2x plus 5 cos power 4 2x minus cos power 5 2x. This is our first term. How we get these coefficients is slightly it comes under a different topic and specifically under binomial theorem. So you can look up for binomial theorem, or you can wait for a few more videos and you'll see that also being covered. So for the time being, just take down this as you can actually even expand it using 1 minus cos 2x squared into 1 minus cos 2x power 5, into 3. That is this thing. If you know binomial theorem, you can directly write it this way. Okay. So this is the first term. Similarly, the second term is actually very simple. Instead of minus here, you will have plus, right, on the odd terms. So you have 5 cos 2x, you have 10 cos squared 2x, you have 10 cos cube 2x, you have 5 cos power 4 2x, and you have cos power 5 2x. And that all is equal to 32 cos power 4 2x, right? So please note that this whole thing here, that those two lines are just the left hand side, and 32 cos power 4 2x is the right hand side, right? Now what I said about interesting here was, you see that all the odd exponents of cos 2x, they get cancelled, right? So you have minus 5 cos 2x, 5 cos 2x. You have this cancels, this cancels, and obviously the other ones, they become multiples of 2. So you have 2 into 1 plus 10 cos square 2x plus 5 cos power 4 2x equal to 32 cos power 4 2x. You can just take 2 common from both, and you have 1 and 16 on the right hand side, 1 on the left hand side, 16 on the right hand side. But what we get otherwise is a very simple thing. You have 1 plus 10 cos square 2x plus 5 cos power 4 2x equal to 32 cos power equal to 16 cos power 4 2x. Now this is nothing but quadratic in cos squared x, cos squared 2x, right? So don't get frightened with thinking that it is a biquadratic. No, it's not. It's just a quadratic. Actually, it's a biquadratic, but taking that as a quadratic solving, you can easily find out the other answers, right? So what we'll do is, 10 cos square 2x and cos power 4x equal to 16 cos power 4 2x. So we'll just take all of them to one side. I'll take all of them to right hand side because I'll have a positive exponent, positive coefficient for cos power 4 2x. That is 11 cos power 4 2x minus 10 cos square 2x minus 1 equal to 0. Now we see that cos square 2x equal to 1 is the solution, right? 11 cos 4 2x minus 11 cos square 2x plus cos square 2x minus 1 equals 0, or cos square 2x minus 1, and the other is 11 cos square 2x plus 1, right? So the roots we get are cos square 2x equal to 1 or cos square 2x equal to minus 1 by 11. Now you see the second one is not possible, right? Cos squared, the left hand side is cos squared. That means the right hand side must be always a positive, right? So but minus 1 by 11 is a negative number, so this is not possible. So we have cos square 2x is equal to 1. Now we can directly write from this, but we'll rather go to this way. We'll write this as sin square 2x equal to 0. Sin square 2x is equal to 0, that means sin x is equal to 0 for, why I wrote it as sin squared is because cos square 2x equal to 1 means cos 2x can be 1 or minus 1, but sin square 2x equal to 0 means sin x is always 0, right? So that gives us 2x is equal to 10 pi, right? X is equal to 10 pi. So we saw here that this seemingly difficult question could be made very simple, just taking into fact that sin squared and cos squared can be written in terms of cos 2x. Right? The next one now. Okay. So cos theta plus cos 3 theta plus cos 5 theta plus cos 7 theta equal to 0. Now for these kind of questions, the addition formula, the addition and subtraction formula is very important. I believe you all still remember all those formulas. Otherwise, you can just look it up while doing these questions. So what we will do here is we will combine cos theta and cos 7 theta. Why? Because you'll see why. So cos theta plus cos 7 theta will gives us two types: cos of half of their sum and half of their difference. Cos 4 theta and cos theta. Similarly, for the ones inside, you get cos of 4 theta and cos of theta. Right? So you see that we got a common argument here, right? Cos 4 theta. And that is the reason of combining cos theta and cos 7 theta. There is no problem. There is absolutely no problem if you take cos theta plus cos theta plus cos 5 theta. At the end of the day, you should get this. You should get the same answer. So you should get the same arguments also. But it becomes slightly easier if you take this. Right? So we take 2 cos 4 theta common, and we have cos 3 theta plus cos theta now. So cos theta. Right. So again combining them, cos 4 theta 2 times cos of 2 theta cos of. So so we see that this large expression is nothing but 4 times cos theta cos 2 theta cos 4 theta equal to 0. Right. So now that means when the whole product is 0, that means any of the terms are 0 or all of them are 0. So taking them as 0, we get cos theta equal to 0. Now what that means? That is theta is equal to 2n plus 1 pi by 2. Right? It can be 90, 270, similarly, or pi by 2, 3 pi by 2, 5 pi by 2. That is written as 2n plus 1 pi by 2. The next one is cos 2 theta equal to 0. Cos 2 theta equal to 0, or 2 theta is equal to 2n plus 1 pi by 2, or theta is equal to 2n plus 1 pi by 4. Right? So this is also a solution. And the final one is cos 4 theta equal to 0, or 4 theta is equal to 2n plus 1 pi by 2. Theta is equal to 2n plus 1 pi by 8. Right? These are the solutions to this equation here. So we see that just writing in, just using the addition subtraction formula, we see that it becomes a whole lot simpler. Right? The next one here. Solve sin squared x minus cos theta, sin squared theta minus cos theta equal to 1 by 4 for theta. Find all the values of theta in the interval 0 less than theta less than 4 pi. Okay, so okay, do note that it's not 2 pi here, it's 4 pi. So whatever we usually take 2 pi, whatever you get in 2 pi, we just add 2 pi to that, and we'll get in the next interval 2 pi to 4 pi. Right? Okay. Now the equation actually is a very simple one. What you need to do is obvious. You have to write sin square theta in terms of cos square theta. You have 1 minus cos square theta. Cos theta is 1 minus 2. Cos square theta plus cos theta minus 3 by 4 is equal to 0. Only this is the minus under the root we have 2, we have 4, so the root of that is 2. Minus 1 minus 2 by 2. That gives us minus 1 plus 2, that is half, or minus 3 by 2. Obviously minus 3 by 2 is not possible. Cos theta is equal to half. Now once cos theta is equal to half, we know that the cos theta is equal to half, that is cos of, writing the general equation, general equation we get, this should be n pi plus Now you see that there's something wrong with this equation, right? Because cos of theta equal half can also written in terms of cos of 2 pi minus pi by 3. So I'm sorry, this is 2n pi plus or minus pi by 3, right? So let's put our the values of n here and see what solution here. So putting n equal to 1, we get theta is equal to 2 pi. Okay, let's put n equal to 0. I'm sorry. So putting n equal to 0 here, we get plus or minus pi by 3, but we need only in the interval 0 to 4 pi. So we'll take the first one. If n equal to 1, theta is equal to 2 pi plus or minus pi by 3. That is 2 pi minus pi by 3. We should write in the ascending order. So that gives us 2 pi minus pi by 3. It's 5 pi by 3. The next one is 7 pi by 3. N equal to 2, the theta is equal to 2 pi plus or minus 4 pi plus or minus pi by 3. Obviously 4 pi plus pi by 3 is greater than 4 pi, so we'll just take the other one, that is 11 pi by 3, right? So the question said solve this. So we have theta is equal to this, and all the angles in the interval 0 to 4 pi is theta specific in this interval pi by 3, 5 pi by 3, 7 pi by 3, 11 pi by 3, right? In the interval 0 less than equal to theta. Okay, so the next question here is cos x minus sin x into 2 times tan x plus secant x plus 2 equals 0. Now this question is be very attentive here, because now on the left term here is cos x minus sin x. None of them have anything in common, and the right one can be expressed in terms of sin theta plus cos theta, and sin theta and cos theta, sin x and cos x. But writing them in that format doesn't seem to be that helpful, right? Because you will have you will be multiplying the numerators in any case, and the denominator will go and multiply with plus 2, right? So doesn't look like it will be much helpful. So what we will do here is we'll try to use the half angle formula. If you remember all the half angle formula, well and good. Otherwise, you can just look it up. That is why remembering these equations or being able to derive them in exams is slightly more preferred. Okay. So cos x can be written as 1 minus tan squared x by 2 and 1 plus tan squared x by 2. And sin x is 2 tan x by 2. 1 plus tan squared x by 2. Similarly, here we have 2 into, there is already a 2 here, so it should be 4 tan x by 2. 1 plus, 1 minus 1 minus tan squared x by 2. For secant, we have just the inverse of cos x. We have 1 plus tan squared x by 2. 1 minus tan squared x by 2 plus 2 is equal to. Now we see that we have transformed this whole equation in terms of tan of x by 2, right? So let's take tan of x by 2 as 3. Right? So rewriting in terms of that, we get 1 minus t squared, 1 plus t squared minus 2t by 1 plus t square 4t 1 minus t square plus t square 1 minus t square plus 2 equal to 0. So let's multiply the whole thing with 1 plus t squared into 1 minus t square. This is 1 minus t square minus 2t is 1 plus t square plus 4t is 2 times 1 minus t square into 1 plus t square. Right? So expanding this whole thing, we get this equation. This is then 6t t square minus 2t minus 3 equals 0. So let's just rearrange these terms to find the roots. Okay, so we see that 3t squared equal to 1 could be a root, right? So write this in terms of this. 6t minus 2t 3t squared minus 1 t squared plus 2t into 3t squared minus 1 or 3t squared minus 1 into t squared plus 2t plus 3 equals 0. Right? So we see that we can factorize these in terms of this, but t squared plus 2t plus 3. Right? But what exactly is t? T is nothing but tan of x by 2, right? So we get t squared is equal to 1, which means 3 times tan squared of x by 2 is equal to 1, or tan squared of x by 2 equal to 1 by 3. Taking the square root, we get tan of x by 2 equal to 1 by root 3. Now tan of x by 2 equal to 1 by root 3 is tan of 1 by root 3 is nothing but tan of 5 by 6. Right? So x by 2 and pi plus 5 by 6. And I get x is equal to 2 and pi plus 5. Okay. Let's take the other root now. With the other root we have, just a second, this was this plus or minus, right? This is plus or minus, we will have tan of plus or minus this and this. Now the other root is t squared plus 2t plus 3 equal to 0. But we know that t squared plus 2t plus 3 can be written as t squared plus 2t plus 1 plus 2. Well, that means t plus 1 whole squared plus 2. But that is always greater than 2, right? So that part will never be equal to 0. So this never gives any solution. T squared plus 2t plus 3 never equal to 0. So this the only solution set will be from the first one, that is 3t squared equal to 1. It gives us tan of x by 2 squared is equal to 1 by 3, and x is equal to 1 by plus or minus 5. So the next question is, if tan of a plus b minus b is equal to 1 and secant of a plus b equal to 2 by root 3, find the smallest positive values of a and b and their most general values. Right. So this is the system of equations I was talking about when I said two equations in two unknowns. Right. So now tan of a minus b equal to 1 Now that is nothing but tan of pi by 4, right? So a minus b can be written as n pi plus pi by 4. Now on the other hand, secant of a plus b equal to 2 by root 3 means secant of, now cos of 30 or cos of pi by 6 is root 3 by 2, secant of pi by 3 is 2 by root 3, pi by 6, right? Now that means so we'll rather turn it into cos. Cos of a plus b is equal to cos of pi by 6, or a plus b is equal to 2n pi plus or minus pi by 6, right? Now let's look at the question. The question says find the smallest positive values of a and b and their most general values. Now if a and b are okay, so let's find some of the solutions for first for a minus b and a plus b, right? So from the first equation, putting n equal to 1, 0, 0, 1 and 2, let's put 0, 1 and 2, we get the values a minus b can take are n pi plus pi by 4, right? So n pi plus pi by 4 gives us pi by 4, 5 pi by 4 and 9 pi by 4. So this one can we'll just keep this for the time being, and we have then a plus b is equal to 2n pi plus or minus pi by 6, right? So putting n equal to 0, we get plus or minus pi by 6. Putting it as 1, we get 2 pi plus or minus pi by 6. Now the question asks for the smallest positive values. That means a plus b must be greater than a minus b, right? Yeah. Okay. So putting these values, we get okay. So now automatically pi plus or minus pi by 6 gets cancelled, and we have this is 11 pi by 6 or 13 pi by 6, right? So let's take 11 pi by 6, let's restrict ourselves to 0 to 2 pi. So this also and these also get cancelled. So you have a minus b is equal to pi by 4 and a plus b is equal to 11 pi by 6, right? Well, sorry, we can have pi by 4 too, right? Nothing wrong with that. So we get a is equal to, just add the equations, we get 11 pi by 6 plus pi by 4. Let's take the first one here, pi by 4. So 11 pi by 6 plus pi by 4 by 2. So this gives us 12 is the common denominator here. So this gives us 3 plus 22 is 25 pi by 24, and b is just subtracted or from any of the equations here, or subtract the equations and you get 11 pi by 6 minus pi by 4, right? That is again 22 minus 3, that is 19 pi by 24. This is for the first set, right? For the next set, we have a minus b is equal to 5 pi by 4, and a plus b is equal to 11 pi by 4. So you get a as 11 pi by 6. That gives us 15 plus 22 is 37. 24. b is equal to half of minus 5 pi by 4. Okay. 7 pi by 20, right? So the question asks for the smallest positive values of A and B and their most general values, right? So these are the values. So from this we have 37 pi by 24. Here we have 25 pi by 24 and 19 pi by 24. Now for the general values, we can write these as we wrote the general values earlier itself. A minus b equal to n pi plus pi by 4, and a plus b is equal to 2 n pi plus or minus pi by 6. So again adding these equations, we get the general solution in terms of a and b as a is equal to half of. Now note that while writing the general solution, you should not write a plus b. You should not write them as the same n, right? So either change the second n to m or the first n to m or some other constant, some other number. Okay, so it's not n in the both the equations. I'll take this as m. Okay, so this is half of 2m plus n plus pi by 4 plus or minus pi by 6, and b is equal to half of 2m minus n minus pi by 4 plus or minus pi by 6. These are the general values, and the smallest positive values were 37 pi by 24, 7 pi by 24 in one case, and 25 pi by 24 and 19 pi by 24 in the second case. Right? These are the general values here. Okay. Let's move to the next question. The next question is an inequality trigonometric equation. So it says sin x is greater than 1 by root 2. Well, in this question, how exactly do we proceed? So the best method of approaching this kind of question is drawing the graphs and seeing where this is a pretty simple one. So you can easily find out where the graph or where the intersection points are, right? So 1 by root 2 is nothing but sine of pi by 4, right? So when I draw the graph of sin x, so on the x-axis I have the argument x, and on the y-axis I have sin x. Okay, I will not draw only sin x. I'll have to draw the constant sin pi by 4 also, which is 1 by root 2. Okay, so first of all, let me draw sin x. This is one side, this is the other side. I'll just restrict it to 0 to 2 pi. This is 0, this is 2 pi, similarly, this is 2 pi. Right? And now I know that this is this is 1, this is minus 1. So 1 by root 2 will be somewhere near here, right? Okay. So our sin x should be greater than 1 by root 2. That means sin x can lie only in this interval. Fine. So now we know what this angle is. This is nothing but a pi by 4. And this one will be just symmetric. This is pi. So this will be 3 pi by 4. Right? So we see that our x can lie only in the interval, in 0 to 2 pi, it will lie only in the interval pi by 4 to 3 pi by 4. So this is written as x belongs to, now this is strictly greater than, so pi by 4 and 3 pi by 4 have to be excluded. So we put a normal brace here, parenthesis. That means the endpoints are not included. Right? So x belongs to this in 0 to 2 pi. So that means, writing the general solution, we'll write this as x belongs to, x belongs to, now, okay. So this is the way to write this kind of solution. So this big U, capital U, but it's supposed to be written slightly bigger. So that this actually denotes union. Now, if you have studied set theory, you will know what a union is. Now, in very plain terms, it means it is the addition of all these this plus this. So all these small intervals, when they are added up, that is called a union. So union of all 2n pi by 4. Oh, sorry. It's not 2n pi by 4. Sorry. So it's 2n pi plus pi by 4 to 2n pi plus 3 pi by 4. Right? So let's take a moment to understand what was written here and how it was written. Right. So first of all, we find out the domain of x. So we see that x can lie only in, say, in 0 to 2 pi, it can lie only in pi by 4 to 3 pi by 4. In minus pi to 2 pi to 0, it can lie only in, so this will be minus 7 pi by 4. This is minus 5 pi by 4. Right? So it can lie only in that range. Now all these domains have to be added up. So that is done using the union. So this capital U does that, and we know that n belongs to integer set. N can take only integer values, 0, plus or minus 1, plus or minus 2, all these values. So, this says that x belongs to this set, and this here says that n is what are the values n can take, right? So x belongs to the union of this set 2n pi plus pi by 4 to 2n pi plus 3 pi by 4, where n belongs to the integer set. Right? So this is how we write the solution. Now the question was not that tough, but the concept introduced here is very important, because a lot of questions will be. Now what we did earlier was just a specific value while writing the general solution, but here we are taking the whole set. That is why union is a very important part. Okay, so let's look at the second question. Second question says cos x is greater than or equal to minus half, but we know that cos of 2 pi by 3 is equal to minus half. So let's take the same approach. Let's draw the graph and see which regions are actually valid. Right? So this is 0 here, 1 and minus 1. So let's draw the graph here. Right. This is minus 2 pi, this is pi here, minus pi. Similarly, this part is pi, and this is 2 pi. For just simplicity's sake, I am taking till only from minus 2 pi to 2 pi. You can actually take further, but it will not be of much use, because for general solution, this much should be enough, right? So we now need to draw the line minus half. That is somewhere here, right? Minus half. So we see that cos x is greater than minus half in this interval. Now this is our minus 2 pi by 3, and this is 2 pi by 3, right? So in all of this, cos x will be greater than minus half, right? Now we see that this part is actually recurring. So we have all of this greater than minus half. Then again from this part till the next one, when we draw like this, so we see that again this part will recur here. Again even here also it will start recurring when you go to the left hand side. So if we can just we can just write in terms of these two angles, or in other terms, x in this small interval lies from minus 2 pi by 3 2 pi by 3. But adding 2 pi to that 2 and pi will never change anything, and that is how actually you get the other terms, right? So this is actually 4 pi by 3, and you can see that minus 2 pi by 3 plus 2 pi gives us 4 pi by 3. Or in other terms, x belongs to the union set. Now here we see that instead of the normal brackets, we write square brackets. Square brackets indicate that the endpoints are included. So 2 and pi, minus 2 pi by 3 to 2 and pi plus 2 pi by 3. Right? So again, let's just understand this answer here. So this means x belongs to the union set 2 and pi minus 2 pi by 3 to 2 and pi plus 2 pi by 3, where n is an integer, right? So from here till here, all the angles are included. Similarly, just add suppose n equal to 1, so add 2 pi, and you'll get from here to the next one somewhere here, all of them will be again included. Similarly, n equal to minus 1 will give us solutions, a complete domain on the left hand side. Similarly, you can find all the solutions, right? So this is general solution. Okay, so in these two questions we see how exactly we can to solve a trigonometric inequality equation. So using the graph is always more preferable, because that will directly show us the answer, because sometimes we may get confused, sometimes we may ignore some domains. So drawing the graphs is the best method. Try to draw the graphs. These are actually very simple ones. Slowly and slowly you get tougher and tougher trigonometric inequality equations. So all you have to do is in the end find out a range for the trigonometric function, draw its graph and find the solution. So thank you for watching this video.